Okay, so this will be a brief video, but I think it's worth being explicit about. Calculus is applied mathematics. It's along with probability, I guess I'd say, it's one of the foundations of applied mathematics. And you sometimes sort of lose that in calculus textbooks. I mean, not ours so much because it's a dedicated applied calculus textbook, but in like Thomas, you'll be taking a lot of derivatives and they won't have any real world motivation. You'll just be practicing the rules. And that certainly has its place. But what I want to emphasize is that we care about calculus because we care about real world functions. And real world functions have units attached to them. And so does the derivative. So if you've got a function, y equals f of x. Presumably in the real world, y and x both have units. And then you take the derivative, and the derivative is a rate of change. The derivative has units as well. And let's use Leibniz notation here, because Leibniz notation makes it looks like a fraction, and it makes it very easy to talk about the units. If the derivative we're looking at is dy over dx, then its units are simply the units of y over the units of x. So if you're looking at a profit function, let's say, and x is the number of widgets sold, and y is the dollars of profit. I guess kind of an awkward way of saying that. But if we take the derivative, dy dx, well, y is measured in dollars, and x is measured in widgets. So this is dollars per widget. Um, if we look at the old thrown object example, which is maybe, I mean, most of you are not in this class, probably as a preparation to take a physics class, so it's a bit far afield. But if you throw an object upwards, you might get a function or an equation like this. Y equals negative 4.9 x squared plus 10x plus 4. And we can take this derivative. Or if we can't, we just need to practice a little until we can, because we have all of the rules we need to take it. So the derivative of a sum is the sum of a derivative. So we just take each of these individual derivatives and add them together. Here, the power comes down. 4.9 times 2 is negative 9.8. The derivative of a constant times the variable is the constant. The derivative of a 4 is 0. So here's the equation. But what are the units? Well, very cleverly, I didn't give you the information you need to answer that question. So, mea culpa. X is the amount of time that's passed since we threw the object. X is measured in seconds here. Y is the height of the object. Y is measured in meters. So the unit that this is taking on is meters per second. The unit of y divided by the unit of x.